This video is called Some Stuff About Stuff, and we're using the two popular meanings of the word stuff. What's chemistry? Well, chemistry really is what chemists do. My mentor, Dr. Pauling, did a lot of different things during his lifetime and even invented a couple of new fields of chemistry. But chemistry is the study of matter, energy, and the reactions that involve matter and energy. One thing that we know is that there is chemical change and there is physical change. Chemical change is a change that you cannot easily reverse. It's a change that requires chemical reactions to reverse. For instance, you can melt ice and then refreeze it very easily. That's not a chemical change, it's a physical change. But if you decompose ice, or liquid water, into hydrogen and oxygen, as you see here with these electrodes attached to a battery, the hydrogen and oxygen come off as gases, and you have to burn the two gases together if you want to get water again. Your lab report should show that solid wax turned to liquid around the wick. That's a physical change. You were probably able to determine that either by pouring the wax off and watching it harden, or by taking a little of the liquid out with a pen tip or something and watching it harden there. So, physical change. Now, this is not a real good statement because it's not a complete English statement. The mass of the wax overall during this process of burning went down. So, it's clear that some of it burned off or even evaporated off. The evaporation would be a physical change, but the burning would be a chemical change. And you can see that the burning is a chemical change. Again, this is not a complete English sentence. How does scientific research grow? Basic research discovers the inner working of chemicals. Applied research takes the basic ideas to solve specific problems. Then the technical engineers take the applied research and can make practical devices out of them. For instance, Joseph Priestley, and about the same time Antoine Lavoisier, discovered oxygen gas. Applied researchers found the heat generated when hydrogen and other fuels would burn in oxygen gas. Then engineers developed fuel cells that were able to react hydrogen and oxygen without burning them together. That's an engineering application to the applied research, and that, of course, all depended on the discovery of oxygen gas. Here's some terms that you might recall from middle school, and you better learn them if you didn't. Matter is anything that takes up space and has a mass, something that we can weigh or mass. Mass is the amount, the measure of how much stuff we've got. It is usually expressed in grams in chemistry. Solids, liquids, and gases all have mass, although gases have a very small mass and it may be difficult to find what it is. And during this course you will find the mass of all three kinds of states of matter. Weight, however, involves how much gravity, the force of gravity pulling on a mass. Weight is not a mass. They're not the same thing. Weight is a force measured in newtons or in pounds. Elements are the simplest particle of matter. We see that everything is made of atoms, and a pure collection of the same atoms, no other atoms in it, that is called an element. These elements cannot be broken down into simpler substances because they are the basic building blocks of matter. You're going to be tested on a number of elements very soon, and make sure that you memorize the list, symbol and name, on your next test. Here's some more terms. Again, an element is a pure substance that can't be broken down further because it's all one kind of atom. This is a picture of sulfur crystals. A compound is a pure substance, all right, but it's made up of a definite proportion of two or more elements. So water, iron oxide, methanol, DNA, those can all be pure substances, but they're made up of more than one element. This is a picture of iron oxide. You can see it's about the color of copper. The penny that you see next to it shows you a color similarity between those two. But iron oxide is not an element like iron or copper or sulfur. It is a chemical compound made up of more than one element. Now let's talk properties. These are characteristics of a substance. The property of color. The sulfur is yellow. Color usually doesn't depend on how much stuff is present. We call this an intensive property because that property stays the same no matter how much stuff is there, small or large. Other intensive properties would be density, hardness, solubility, and water. You may be able to think of other intensive properties that don't change if you add more of it. Now, you can see that in mass, the more there is, the more mass there is. Volume as well. The more volume there is, the more space it takes up. And so similarly, length, width, and height are what kind of properties? They do depend on how much is there. And you may be able to think of others. Watch the sulfur. It's all sulfur. It's all sulfur no matter how much there is. But when we measure how much there is, we're measuring an extensive property. These properties extend, so they are extensive properties. Looks like I need a little training in this one too. Intensive properties don't depend on how much there is. Extensive properties do. Let's look at physical versus chemical change and properties. Physical properties can be determined without a chemical reaction, without changing the identity of the substance. So you can find the color, the mass, the hardness, the density without doing any chemistry on it. But chemical properties can only be determined by reacting the substance and therefore changing its identity. So chemical reactivity, a type of which is flammability, a type of which is corrosion. Those are chemical properties. But once we have determined what the chemical property is, if it's a positive, if it is flammable, if it is corrosive, we will have changed that particular substance to another substance. Let's talk about the states or phases of matter. Generally solid, liquid, and gas. Solids keep their shape and size. Liquids keep their size but will fit any shape. And gases can expand into any size and take any shape. The solid to liquid phase change is called what? The liquid to solid phase change is called what? And the liquid to gas phase change is called what?